Introduction. Total mass of the products remains equal to the total mass of the reactants. H2 plus Cl2 gives 2HCl. A chemical compound always contains same elements combined together in same proportion of mass. Ice H2O 1:8. River H2O 1:8. Sea H2O 1:8. Objectives. At the end of this lesson, you will be able to determine significant figures, explain various laws of chemical combination, describe the terms atomic mass, average atomic mass, molecular mass, and formula mass, mole. Calculate the mass percent of different elements constituting a compound. Determine empirical formula and molecular formula for a compound from the given experimental data. Perform the stoichiometry calculations. Dimensional analysis. Often while calculating, there is a need to convert units from one system to other. The method used to accomplish this is called factor label method or unit factor method or dimensional analysis. Laws of chemical combination. The combination of elements to form compounds is governed by the following 5 basic laws. Law of conservation of mass. It states that matter can neither be created nor destroyed. For example, reaction of one molecule zinc react with one molecule of sulfur to form one molecule of zinc sulfide. Law of definite proportions. This law was given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. In formation of water compound, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Law of multiple proportions. This law was proposed by John Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. Example: 100 grams of carbon may react with 133 grams of oxygen to produce CO, or with 266 grams of oxygen to produce CO2. The ratio of the masses of oxygen that can react with 100 grams of carbon is 266:133, or approximately 2:1, a ratio of small whole numbers. Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac in 1808. He observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Thus, 100 ml of hydrogen combine with 50 ml of oxygen to give 100 ml of water vapor. Hydrogen plus oxygen gives water. 100 ml plus 50 ml gives 100 ml. Thus, the volumes of hydrogen and oxygen which combine together, that is 100 ml and 50 ml, bear a simple ratio of 2:1. Avogadro law. In 1811, Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. Avogadro made a distinction between atoms and molecules, which is quite understandable in the present time. If we consider again the reaction of hydrogen and oxygen to produce water, we see that 2 volumes of hydrogen combine with 1 volume of oxygen to give 2 volumes of water without leaving any unreacted oxygen. Dalton's atomic theory. Dalton proposed the following points. 1. Matter consists of indivisible atoms. 2. All the atoms of a given element have identical properties including identical mass. Atoms of different elements differ in mass. 3. Compounds are formed when atoms of different elements combine in a fixed ratio. 4. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Atomic mass and average atomic mass. One atomic mass unit is defined as a mass exactly equal to 1/12 the mass of one carbon-12 atom. And 1 AMU is equal to 1.66056 into 10 raised to the power minus 24 gram. Mass of an atom is equal to 1.6736 into 10 raised to the power minus 24 gram of hydrogen. Thus, in terms of AMU, the mass of each atom is equal to 1.6736 into 10 raised to the power minus 24 upon 1.66056 into 10 raised to the power minus 24, which is equal to 1.0078 AMU, which equals 1.0080 AMU. Similarly, the mass of oxygen 16O atom would be 15.995 AMU. When we use atomic masses of elements in calculations, we actually use average atomic masses of elements. Example: the average atomic mass of carbon isotopes will come out to be 0.98892, 12U plus 0.01108, 13.00335U plus 2 into 10 minus 12, 14.00317U is equal to 12.011U. Molecular mass and formula mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. Example: molecular mass of methane. CH4 is equal to 12.011U plus 4 into 1.008U is equal to 16.043U. Similarly, molecular mass of water H2O is equal to 2 into atomic mass of H plus 1 into atomic mass of O is equal to 2 into 1.008U plus 16.00U, which is equal to 18.02U. The formula such as NaCl is used to calculate the formula mass instead of molecular mass, as in the solid state sodium chloride does not exist as a single entity. Thus, formula mass of sodium chloride is equal to atomic mass of sodium plus atomic mass of chlorine is equal to 23.0U plus 35.5U, which is equal to 58.5U. Percentage composition. The percent composition of a compound is a relative measure of the mass of each different element present in the compound. Calculate the percentage composition by weight mass of element is equal to total mass of element present divided by molecular mass into 100. Empirical formula for molecular formula. Empirical formula of a compound shows the ratio of elements present in a compound. Molecular formula of a compound shows how many atoms of each element are present in a molecule of the compound. The empirical formula mass of a compound refers to the sum of the atomic masses of the elements present in the empirical formula. The molecular mass, formula weight, or molecular weight of a compound is a multiple of the empirical formula mass. mm is equal to N into empirical formula mass. Empirical formula can be calculated from the percentage or percent composition of a compound. Examples of empirical and molecular formula. If carbon and hydrogen are present in a compound in a ratio of 1:2, the empirical formula for the compound is CH2. The empirical formula mass of this compound is 12.0 plus 2 into 1.0, which is equal to 14.0 g per mole. If we know the molecular mass of the compound is 28.0 g per mole, then we can find the molecular formula for the compound. mm is equal to N into empirical formula mass. 28.0 is equal to N into 14.0. So N is equal to 2. So the molecular formula for the compound is 2 into empirical formula, that is 2 into CH2, which is C2H4. There are many compounds that can have the empirical formula CH2. These include C2H4, ethene or ethylene. Molecular mass is equal to 28.0 and N is equal to 2. C3H6, propene or propylene. Molecular mass is equal to 42.0 and N is equal to 3. Stoichiometry and stoichiometric calculations. Stoichiometry deals with the calculation of masses, sometimes volumes also, of the reactants and the products involved in a chemical reaction. Example, CH4 plus 2O2 gives CO2 plus 2H2O. The coefficients 2 for O2 and H2O are called stoichiometric coefficients. Similarly, the coefficient for CH4 and CO2 is 1 in each case. Thus, according to the above chemical reaction, 1 mole of CH4 reacts with 2 moles of O2 to give 1 mole of CO2 and 2 moles of H2O. 22.4 of CH4 reacts with 44.8 of O2 to give 22.4 of CO2 and 44.8 of H2O. 16 gram of CH4 reacts with 2 into 32 gram of O2 to give 44 gram of CO2 and 2 into 18 gram of H2O. Mole concept and molar masses. 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 gram or 0.012 kg of the 12 carbon isotope. 1 mole is known as Avogadro constant, denoted by Na. Hence, so many entities, atoms, molecules or any other particle constitute 1 mole of a particular substance. Or we can say that 1 mole of H atoms is equal to 6.022 into 10 raised to the power 23 atoms. 1 mole of water molecules is equal to 6.022 into 10 raised to the power 23 water molecules. The mass of 1 mole of a substance in grams is called its molar mass. Molar mass of water is equal to 18.02 gram. Molar mass of sodium chloride is equal to 58.5 gram. Reactions in solutions. The concentration of a solution or the amount of substance present in its given volume can be expressed in any of the following ways. 1. Mass percent or weight percent. 2. Mole fraction. 3. Molality. 4. Molarity. Terms expressed concentrations. Percent composition by mass. We can consider percent by mass or weight percent as it is sometimes called in 2 ways. The parts of solute per 100 parts of solution. The fraction of a solute in a solution multiplied by 100. Percentage by mass is equal to mass of solute upon mass of solution into 100. Molarity. Molarity tells us the number of moles of solute in exactly 1 liter of solution. Note that molarity is spelled with an R and is represented by a capital M. Molarity is equal to mass of solute upon volume of solution, liter. Molality. Molality tells us the number of moles of solute dissolved in exactly 1 kilogram of solvent and represented by a lowercase m. Molality is equal to mass of solute upon mass of solution, kilogram. Mole fraction. The mole fraction, X, of a component in a solution is the ratio of the number of moles of that component to the total number of moles of all components in the solution. XA is equal to moles of A upon moles of A plus moles of B. XB is equal to moles of B upon moles of A plus moles of B. Did you know, according to modern atomic theory, atom is divisible? Same atom may have different atomic masses like 1H, 2H and 3H. Different atoms may have same atomic mass like 40 Ca and 40 Ar. Atom is the smallest particle that takes part in a chemical reaction. The mass of an atom can be changed into energy. Summary. Let us summarize what we have learned. All these laws led to the Dalton's atomic theory, which states that atoms are building blocks of matter. The atomic mass of an element is expressed relative to 12 carbon isotope of carbon, which has an exact value of 12. The molecular mass of a molecule is obtained by taking sum of the atomic masses of different atoms present in a molecule. The quantitative study of the reactants required or the products formed is called stoichiometry. The amount of substance present in a given volume of a solution is expressed in mass percent, mole fraction, molarity and molality. The number of atoms, molecules or any other particles present in a given system is expressed in the terms of Avogadro constant 6.022 into 1023. This is known as 1 mole of the respective particles or entities.